Awesome. So how many people are familiar with Git, just sort of as like an idea out there? All right, so most people have heard of it. Yeah. Thomas has. All right. All right. So what we're going to be talking about today is version control with Git, and I'm going to apologize. I have some slides, but I can't split the screen.
But all of the slides are in the repository you downloaded.
They are.
You can open up the slideshow on your computer.
You can open up the slideshow on your computer.
The file.
Should I show them where it is? Well, have they cloned it? I don't know.
Yeah, we cloned yesterday.
We cloned yesterday, okay.
So you just have to navigate.
You just have to navigate to it, okay. So I will show you where that is. Except I can't remember where it is on my computer. There it is, 25. Yeah. So the slides I'm going to be showing you are the slides local version control.
And this is in the repository that we cloned yesterday, the SciPy 2015, no, the 2015 0706 SciPy folder.
So if you want from a terminal, you should be able to just, if you're in a Mac anyway, hit open and that should open it up for you in a web browser.
You guys want to put your green stickies up when you're there? Red sticky up if you want help getting there.
All right, look at those green stickies.
So you guys green postage up if you're done?
Yeah. Is there anybody? I see a dearth of
Do we need
green
to?
stickies. You don't need to.
You don't need to. It's just
It's a matter of convenience. I just want to make sure nobody is sort of snagged is all before I move forward. Is there anybody who is having trouble that just hasn't put up a red sticky? I see a couple in the helpers. All right. So let's just begin with just an overview of what version control is. I should stand here for the mic, right? So let's begin with an overview of what version control is, just so everybody is on the same page. I know some of you are familiar with it. Essentially, version control is just a really fancy way of tracking the history of any file on your computer, essentially. It's most commonly used for text and used in the context of your code that you'll write, but you could use it for any kind of text-based document, like a LaTeX document. If you guys write in LaTeX, that can be tracked with version control. Pretty much anything. It's really useful as an individual. I certainly use it all the time with coding projects where it's really just me and I want to keep track of versions, and I use it super diligently when I've got collaborators and we're collaborating on a piece of code. That's when it's probably even more useful. And so this, in case you guys can probably all see it on your screen, so this is sort of the classic quintessential comic, the final doc. I had a lot of these for manuscripts in like 2008, 2009, when I was an early PhD student. I had lots of final doc, and then like final v2 doc, and then the real final v2 doc, and on and so forth. And version control essentially is a solution to that problem. So you no longer have 25 different final .doc iterations, and then you actually have no idea which one is the final, other than saying, I'm just going to sort these by date modified, and just hope that I actually modify them in sequence. The version control essentially takes care of all that clutter for you and leaves you with a single file that you have the history for. So do you guys have any questions about sort of what version control is or when it might be useful? No? All right. Awesome. So the first thing that I want to make sure is that we've all configured. Did you guys all configure yesterday to set up with Git? Or have you guys not?
We cloned a repository.
We cloned our repository. Have you guys gone through these sort of steps up here? All right, great. So let's start with just setting up a configuration. So it's going to be a little tricky for me because I already have a configuration set up. And we can actually just check and see what your configuration is. You can type git config. And all the commands, by the way, that we'll be typing with git start off with git and then some commands. So they'll all be prefaced with git. Sorry? Oh, we should be in a terminal.
Oh, yeah, get them out of their folder.
No, I'll go through that, but the configuration, it doesn't really matter where we are right now. Because we're going to set this all globally. So you guys can type git config -- list. And that'll let you guys know what sort of configuration you have set up. So if you have nothing set up, it shouldn't, none of these fields should be here. In my case, I've already got it. It's a couple things set up with my email and my name. So you guys are going to want to do these because every time you make what's called a commit, and we're going to go over what that means, essentially you need to tell the system who you are, who has made this particular change to the file, and this is the way of setting those options. So we just have some pretty basic things to set. So the first thing we're going to do is type git config -- global. And the global says we're going to do this for all other repositories on this computer. And then the field we want to set is user.name. And then just open quotes. You can give your name and hit enter.
Do most distros come with Git now? Or do you have to separately install it?
Of distros of Linux, you know, I don't know because I haven't installed a Linux distro in a long time. I don't know if somebody else can answer that.
On Apple, does it come on Apple? Or you have to
It doesn't come on Apple, or if it does, it's a very old version that probably needs to be updated.
I don't think it comes by default.
Yeah.
Easy to install. Have you got to
Yeah,
install?
I did.
Yeah, I think
So all of these are going to be git config -- global. The next field we're going to set is our email, user.email. And then again, the value you want should be enclosed in quotes. And so this is sort of the bare minimum that we want, but Git outputs a lot of stuff in different colors, and so we'll see there's a lot of text that's going to be output on the terminal, so it's nice having colors. So there's an option for setting some color flags. So git config -- global, and then we're going to set this flag color.ui auto. All right, and then the last thing we're going to do is this one's going to be a little more tricky. So not to jump too far ahead of myself, but we're going to, every time we sort of save and archive a change to a file, which is called a commit, we're going to leave a message with that. And there's a couple ways of doing that. One is you can just leave it on the terminal, which we'll cover, but another way is you can set up a text editor, which will basically, every time you save these changes to the file, it'll open up your text editor. So a safe bet, and what we're going to do is we're going to configure default manager for that. So the safe bet for most people is probably git config global core.editor is the field. Now, there's a lot of things that you can choose. Nano-W, this is a good bet. I'll use that just because we'll probably use that, but if you use something else, whether it's,
If yesterday you didn't get Nano to work, then, and you were using Notepad instead, you probably want to put Notepad instead of Nano.
I think with Windows, you have to set the full path to it. At least that's how it's listed in the notes. But you could type something else. So if you use, say, Sublime, I don't know if anybody uses Sublime, SUBL will work, but safe bet is Nano. All right, so once you guys have that all set up, let's do git config -- list. And make sure you guys have options that look something like this. Don't worry about that one, but you guys should have your username, your user email, the color, UI, auto, and your editor set. So if you guys could put up a green sticky when you've got all 4 of those fields set, or a red sticky in case you haven't had some trouble with it.
We have a lot more lines. I have a few lines.
You have a lot more,
1,000 lines on the list.
you have a,
Yeah, already, I like to have a remote version.
yeah, it's because you're already in the repository. So it's showing you some local options for within the repository as well. So you type cd space, cd space, sorry, dot.
So when I did that CD, I already.
Oh, yeah, okay. So now I'm running config.
Okay.
Now I'm running config. Sorry. I know, let's get.
Okay, what
Not git. Space. Dash. Space.
Yeah.
So now it's got.
Oh, okay, so,
Yeah. So if you were working in your repository, it's going to give you all the options that are set for that repository, like the remote, and we're going to cover that stuff later on today, but it's going to give you all those options and the other ones. So you could just do something like cd space tilde. That'll bring you out to your home directory where hopefully it's not under version control. And then try git config -- list in case you guys want to see something that mirrors more what I've got up on my screen. In fact, because we're going to create a new repository now, we're going to initialize it, why doesn't everybody sort of get out of the SciPy directory in case you're in there, if you were there to open the slides. And so what we're going to do is we're going to make our first directory, and we're going to put it under version control. So if you're at the command line, you're going to be something like mkdir. And then wherever you want to put it, I'm going to put it in my workspace directory. Oh, no, I don't, because I already got something there. I won't put it there. So here's mkdir planets. So you're making a new directory called planets. We're going to cd into that. And you guys should see that there's nothing in there. So the first thing that we want to do is put this directory under version control, which is saying that we want the ability to track the history of all the files that are within this directory. So we can do that with just git space init, and that's going to initialize a git repository. And so every subdirectory and every file within this directory is going to be tracked within this version control system. So now what you can see when you type ls is it still looks like nothing, but actually if you type ls-a, you can see that there's a new directory that's hidden. So hidden directories, right, they start with a period. So you guys can see it says .git. And so that's the hidden directory that's going to store all of the changes of all the files.
You have a fancy prompt or something like
I do have a fancy prompt, and I feel like maybe I should just get rid of my fancy prompt, just to make sure everybody's on the same page with me. Yeah, I don't want to confuse everybody, and the fancy prompt tells me a bunch of stuff about the repository that we will cover later on this morning, but I don't want to get too far ahead of myself. Well, you can make it wherever you like on your system.
Just make sure it's not in anything you were working in yesterday.
Yes, that is a very good point. You don't want it to, don't make the Planets directory, say, within the SciPy repository that you were just in. So it might be easiest to just say cd space tilde, that'll bring you back to your home directory, and then mkdir planets. So that'll create a directory called planets in your home directory that should be clean. All right, so once you guys have accomplished this task, we started it. One of the things that you will find yourself doing a lot with this directory that's under version control is you're going to want to know what's the status of all the files, right? So again, think in version control, what we're doing is we're tracking all these different versions of all these different files. And there will come a time where you're probably working, you'll have files that are under various sort of phases of work, and you're going to want to know what's the status of those files. So there's a command, git status. And that's going to tell you the status of all your files. And what we're doing is just to show you guys that it says nothing has happened yet. That's essentially all this says. So if you type git status, it says what branch you're on, and then Azalee's going to cover branching in a little bit, what commit we're on, and if there is anything to commit. So it says we're on branch master, initial commit, there's nothing to commit. So basically it's just saying nothing has happened, and I know that nothing has happened. All right. So this is essentially, we have now put this directory under version control, and we are ready to do something exciting. So the first thing we're going to want to do, obviously, is create some files to actually track. And Git works, I mean, Git can technically work on binary files, but it doesn't, it's really meant to work just on text files. So we're going to edit some plain text files. And so because this is a directory about planets, I'm going to type nano mars.txt, and so I'm going to write some sort of text about Mars, all the things I know about Mars. And you guys don't have to use nano, you can use whatever editor you'd like to. So I may say something like cold and dry, but everything is my favorite color, and I'll spell it with a U. And so then I'm going to save this. So now if we type ls, we can see that I have a file, mars.txt, in my directory. See what it says with cat, so just send it out. This is, Mars is cold and dry, but everything is my favorite color. Is that true? Is Mars really cold and dry?
There's
Yes.
evidence of water that's ice.
Well, it's cold though.
It's farther out from Earth, and yeah.
I just want to verify the truthiness of the statements I'm writing, since I'm not an astronomer. So we've added this file. So what do you guys think would be like the next logical thing? We've added this file to our version control. So what would be the next thing we might want to do under version control? Status. Yes, exactly. So we want to say, hey, we've added this file. So what does Git think of this file?
It's an interloper.
Okay. So you can see here that what Git is doing is it's recognizing that there is now a file in this directory. This file is mars.txt, and it's untracked. So Git's saying, hey, I know there's a file in here. I'm not going to do anything with it. And throughout this lesson, by the way, I will definitely personify Git. So what we're saying here, again, Git has this file, knows it's there, and it's just going to let the file just hang out. Just be cool, but not do anything with it. But that's not really what we want. We want our file to be tracked, right? I mean, if we didn't want any files to be tracked, we wouldn't go through this exercise at all, right? So the first thing we need to do is add the file. So we type git add mars.txt. And then next thing you want to do after we've added mars.txt is check our status again. And so what you'll see is it's changed. So in our previous status is red, right? And this is why we set the color, so you know when it gets, letting you know something maybe bad is happening, like maybe you want to track this file. We added it. So now it says there's changes to be committed. And there's this new file, mars.txt. So now Git knows that I want to keep track of this file, but it's our job to say when we're ready to basically take a snapshot of the changes that we've made to our files. And so this snapshot of the changes that we've made to a file is what's called a commit. And this is sort of like one of the most sort of important concepts in Git is this notion of a commit. So I could change this file 100 different times, right? Git doesn't keep track of every single change I make. Git keeps track of only the snapshots that I take, right? So all of these things, I can add 100 more lines, and I could save between each line, but once I make that first commit, it's just going to save those 100 lines. So what we want to do is take a snapshot of our file now. So that's the commit. Git commit. We're going to use the flag -m. So -m is going to let us leave a message about our commit. And essentially, the commit messages are ways of leaving a little note for yourself, for your collaborator, saying, hey, here's what I did, right? I made all these changes, and here is the reason that I decided to archive my changes right now. When you're coding, often you might say, oh, I fixed, if you have an issue tracker, it might be I fixed this particular bug, or I added this particular set of features, right? It's good practice to leave meaningful commit messages. You don't want to be lazy like I am 85% of the time and leave messages like, oh, just committing some stuff, just saving some stuff, and then you have to go back and figure out, maybe you want to go back to a different version, which is something I'll cover, and that's one of the real strengths of Git, is that you can roll back to different versions. How helpful is it to roll back to this version where I left a message, hey, I committed some stuff, right? That's pretty meaningless. So you want to leave something meaningful. I will try and do that to sort of practice what I'm preaching. So I'll say initial thoughts on Mars. Okay, and so once you've done this, you'll see there's a little output summary of what we've accomplished. So it's showing me what my message is. It's also giving me just a little snapshot of what I've done. So it says I've changed one file, I made one insertion, and so an insertion in Git is a line change, right? So Git archives everything by lines. So if I had a single line of text that just wrapped and wrapped and wrapped and was 100,000 characters long, and I changed one letter in it, even though it might look like it's 1,000 lines of text, I've still only made one change because it's archiving it by line.
Can you just comment on carriage return line feed versus line feed and different, someone got an error message on that. If you
It
have
says-
on a Windows box and you're committing to a Unix system and your carriage return line feeds are different.
Oh, so one's /n and the other one's /r.
It says warning LF will be replaced by CRLF in mars.txt.
I actually, when I set it up, I chose how
Uh-huh.
I wanted to do it, but I don't know if anyone else is getting it.
I have not.
Yeah, I figured people would be getting it, some people wouldn't.
I don't think it's anything you need to worry about.
Yeah.
In the real world, though, I mean, if you're developing on a Windows box and you're committing to, it is something you do have to worry about, because you'll end up having everyone else get mad at you. But, so if you don't want to cover it, that's fine.
So I would be happy to cover it if I have ever encountered it. I've never developed on Windows, so I.
You know, a document describing what to do, you can put that in the path for people,
Okay.
that would be helpful. None of us have Windows machines.
Oh, okay. I think when I set it up using the Git GUI, I think it told me that I had options, and I picked the option to make it so that I wouldn't be having this over, oh, don't worry, I'm not having it.
Okay.
but It's just something that, I don't know how many people are doing cross-platform anyway, but
Yeah.
anyway, sorry.
Oh, no, that's fine.
Didn't
No,
mean to
no,
interrupt.
totally, that's a
It
great
looks-
point.
There's actually there's a Stack Overflow.
Yeah. I mean,
About
it's
return
Yeah,
energy.
we'll put something in the
Okay.
Etherpad that,
Okay.
So we've taken you through our Git statuses, and it's always just helpful. I do it all the time to just type Git status to just see where we're at. So now, again, we've gone from there was nothing. We created a file, and it said, hey, there's a file that's untracked. And then we added the file, and then it says, hey, there's a file that's ready. It's what's called staged, so it's ready to be committed. Right? We made our commit. Again, that's taking a snapshot of our status. And we get a little message about it, and then if we type git status again, it says on branch master, nothing to commit. So again, it's just letting you know that, all right, you guys, you're all caught up. There's files, and you've archived and taken snapshots, and everything is ready to go. So now that we've made our first commit, what I wanted to do was have us do our first exercise. So what I want to do is just create a file called jupyter.txt, add some thoughts on Jupyter or anything. It doesn't necessarily, we're going to reference this file Jupyter. You could use a different file if you'd like. And what I'd like to do is just go through and sort of recapitulate the steps that we just did. So you're adding another file, and then I'll start tracking and recording that. So create the file, add it, and then commit those changes, and then put a green sticky up when you're done, or a red sticky if you need help. Okay, it's starting to look like people got this. So I will also do this. And so again, just to kind of quickly review, you guys created a file, jupyter.txt, added some text to it. And I'm going to add my Jupyter file. Just check my status on the way. So now it's ready to be tracked. All right. I'll add this. Deep insights into Jupyter.
You ever do an add without a commit? It seems like you're always pairing them together.
You cannot add files without committing them. Sorry, you cannot commit files without adding them first. And
so, when you add a file, it says, when I commit, I want you to remember what my file looked like now. So typically, you want to add and then commit, because you don't want to say, okay, remember what my file looked like now, then change your file, but then not save what that file change looked like. So very often you're doing the two in sequence. But sometimes you may want to add, like, let's say 3 files and commit them all together, because the change you made is maybe in 3 different files, but it's all working towards a single bug fix or something. And so that's why you're not, add and commit aren't linked, because you want to have, let's say, like 3 different files, and then you want to save what all 3 of those files looked like at the same time. So that's why you have these 2 separate commands, but you are very often doing them sequentially.
yeah, but and correct me if I'm wrong, you cannot commit a file unless it's been added.
Correct.
Yes. So you do have to add a file. You don't have to add them. We're going through this and we're adding them sequentially, but again, like Azalee said, you can add, if you could change 100 files and then just one command, add them all, and then commit them all at the same time. So you don't have to add each file and then commit each file, right? The commit, we've been working one file at a time, but the commit and the add work on the entire repository, the entire directory as well. So we've made our first set of changes, and this is great. So we've got this version we can go back to. If you want to see what we've done, there's a log command. So git log. And what this will do is it's going to show you all of your commit history. So ours it's pretty short right now. This can become very, very long. And you can see the sort of anatomy of a log is it gives you there's a hash that's set up for the commit. We're going to use this in a little bit. This is a way of referencing this particular commit. And then here's that author stuff that we set up, so you know that it was me that committed it. And here's my email address in case you're particularly unhappy with my commit and you want to email me, or happy with it. When it happens, and then what the commit message is.
Hash is pretty long.
Yeah, it's pretty long. You'll see that we don't actually need to know the whole thing, though. And so again, you can see here why one would want to have nice, meaningful commit messages. You can imagine that there's 200 of these commit messages. And maybe I want to do something really cool, like what we didn't cover, but maybe you read on your own, which would be to pipe all of this commit history out, right? Like pipe our log file out, and then use, say, grep at the shell to search for something. It's not particularly meaningful if all of my commits are basically the same message over and over again, which is, again, my personal bad practice. I will say I'm a bad example. And it's definitely made my life difficult at times to say, hey, I committed today. Like, here's a wrap-up of everything I did. And I don't actually say what any of those things are. All right, so now what we want to do is make another change to our file because, again, you can imagine you're working sequentially on a set of files. So I'm going to open up my mars.txt file again. And I'm going to say something like, the 2 moons may be a problem for the Wolfman. Wolfman, it's a proper noun, right? I'm going to save my file and type git status. Okay, so maybe you guys have noticed this. At this point, Git is actually kind of good at guessing maybe the things that you might want to do. And when you type git status, it's actually giving you some helpful hints. So what it's telling us here is that we've got one file that's modified, and it's red saying, hey, this has changed from the last time I saw it, but the changes aren't staged for committing, so they haven't been added yet. And you can see that says no changes added to commit. And it's saying, hey, here's some things you might want to do. You might want to say git add or git commit -a. There's some other stuff, and we're going to discuss these other commands up here. But it's basically guessing that maybe you want to make some commits. And we do want to make some commits. But before we do that, because maybe I changed this file 5 days ago and I don't remember what I changed, or maybe somebody else has happened to change it, there's a diff command called git diff. And what this is going to do is this is going to output the changes between the current version of my file and then the last snapshot of the file. And so this happens to be doing it for mars.txt, but if you just were to type git diff, it should give you all the differences among all the different files in their previous versions that you would have. So we should be able to do git diff just a single file. Either one works for our purposes right now. So what is this telling us here? It's giving us the 2 different versions that we've got. It's saying, so up the top it says mars.txt. It's saying here's the diff. And it actually uses the diff command in Linux. It's just giving sort of the syntax up there. It's giving us the hash for that. And then this is a summary of our changes, the differences. So the other one was missing a line. My new version of mars.txt, I added a line on line 2. And then actually giving us a summary of what those changes were. So here's the black text. Is a text that was in the last snapshot, and this green text with a plus sign next to it is the text that I added, but I haven't committed yet. Right? Yes?
If you had, say, 100 lines and you just and it's not clear, second commit to Excel,
it's not, well, it's gonna show you, it's not gonna show the entire file necessarily, but it's gonna show you all the things you added. So, right now, it's showing this in green because we added something. If I had deleted a line, it would show that line, the minus sign, and it would be in red. Oh, has everybody figured out, by the way, how to get out of these messages? I think it pipes to less. You can just type Q. Not sure. So now we're going to add it. So we want to sort of add these. So what I'm going to do is I'm going to type git add. You can see, OK. Now it's recognizing that what I want to do is I've staged this particular file. It's ready to be committed. I will give it my meaningful commit message. Git commit. Here, actually, I'll just show you guys what it looks like if I don't add, right? So when I don't add the -m and leave a message, it's going to open up my default text editor. And so here I can actually add some things. So, I'll say, added all my concerns about the trip to Mars for the... And now the reason that you might want to have this pop open is a good commit message is probably going to be, in practice, longer than what you're just going to leave at the terminal. The terminal is really, it's good for relatively short commit messages with that -m flag. But if you want to leave something longer or something that has line breaks or anything like that, you'll probably want to open up in your default editor. Okay. And if we type git log, you can see now that I have my nice long commit message right up there. So I think at this point, it's probably useful to just take a quick look at our slideshow here and to see the process of Git. So we've run a couple commits and had a chance to sort of get used to that workflow of making changes, adding those changes, committing those changes, and just getting used to sort of checking the status, leaving our commit messages. So what's actually happening? There's sort of, broadly speaking, there's 3 different major areas when you're working in your Git system. So here's what we're doing when you edit your file. And so if a file is sort of sitting here in just the regular visible file system, essentially you can manipulate it, make changes as you want, sort of ad nauseum. Once you're happy with those, what you want to do is you want to move it to what's called the staging area. So you're saying, hey, I want to track this file and I'm ready to commit those changes. So that's the git add, and that's what's called staging a file for commit. So you haven't actually committed the changes, but you have sort of proudly announced that you would like to save those changes. So you can do this. There's lots of ways you can do this. You can have lots of files that you're editing at any one time, and then you can add them all. There's a flag for the add command that will let you add all the files. This is maybe not the best practice because it does add everything without you necessarily taking the time to think about it.
Does it just add the ones that you've edited? So like all the unchanged files are not added?
It'll add everything that's untracked.
Oh.
Yeah, so any file that happens to have ended up in that, Git repository directory that's untracked will get added to the system.
So you really do have to do the git add. You can't just do git commit.
Well, so there is a flag to the commit. There is a commit flag. I'll cover it just because it's sort of a convenience that I often use. So if a file is untracked, you have to explicitly add it. You have to say git add.
But I mean, after you've already added it and committed your first initial commit, then the next time you change that file, you have to add it again?
You do have to add it again, but there is a flag with the commit command, which is -a, that will let you basically add and commit that file.
Oh.
All in one command line. So you don't necessarily have to say git add file and then git commit file.
Okay.
I'll do that for the next commit just to show you.
I didn't understand what that was about. Okay.
Yeah, so once you have all of your files added, then the commit is the snapshot, right? So these are sort of the 3 phases of your files working through Git. So there's untracked, where You are manipulating the file, and Git just knows that it's there. It's not really doing anything with it. There's a staging area where you have said, I want to keep track of the changes in this file. And then there's actually committing the file, right? And then this, there's theoretically an arrow that goes right back to here. Oh, yes.
So I understand it's a committing goes to per message, but if you ever wanted to edit the comment that you use, is that just to turn it down? If you wanted to
Yeah.
edit something, you know,
There is a way to do it.
You can, it's generally, you
not-
want to write your commit message so you don't have to edit it, but there are capabilities that you can go back and edit it if you need to. So Git is, like, there are a lot of options. There are books written about, Git. So there are ways that you can modify what your history looks like, there are ways that you can modify what your messages look like. And at the end of one of these presentations is a resource for just like a free online book that I found really useful once I had kind of gotten started to just learn about more of that kind of details.
But they don't consider it hacking the repository or anything like that.
So once you start changing what you've done, you're now kind of modifying you're modifying the view for future users of what you've done, and kind of the whole point of this is to save exactly what you did. And so if you start then messing around with that, the fear is that what was actually done to the files and then what you say you did to the files could not be the same.
Yeah, there is, I think, a standard. Oh, sorry, go ahead, Matt.
Like, if you want to change your commit message right after you did the commit, like you forgot to say something, or just type that you want to fix something, like that's not the problem. You can do that, and there's an amend. You can do git commit dash amend, and that will open it up the editor again, so that you can change the message and resave it. But once you are like changing something that's like a month old, or changing something that has gone out into the world and that people now have, is more troublesome. And in that case, it's something you probably want to go ahead and leave it alone. But I quite frequently like make a commit and then I'm like, wait, I didn't say something in there, or I forgot to add a file to that, or something, and I use the dash and flag like immediately afterwards, and that's just fine.
Yeah, I would second what Matt just said. I mean, people go to incredible lengths to preserve the Git history. At Software Carpentry, I remember there was this long threads because we've now gone over the lessons thousands of times of like, and transitioning it from different version control systems and how do we maintain the history of commits, because it's so, like, having that history was so important. So I think that's just generally the best practice. So there's just a couple other things, and I just want to cover just so we can, we'll wrap up sort of this process of committing and adding files. And so to do that, I'm just going to edit my, I've done too much, there we go. I'm going to edit my file again, and so I'm going to set my Mars file again here. And so I just want to kind of go over a couple more things about looking at diffs and staging files. So let's see if I haven't added my file. So now if I say type git diff, just typing git diff is just going to give me the difference between my different files that I've got. We've seen this. And again, you can see where, I've added my line on the third line here with a quick summary that's in blue. The green is showing me the actual set of changes there. Now if I type git diff, sorry, I did that pretty quickly. So I typed git add mars.txt. I type git diff, and I get nothing. Right? So when you just type git diff, if you don't actually say, I want to look at the difference, and we'll go over this in more detail, where you can look at the difference between pairs of commits. But if I just type git diff, and I've already staged my files for commit, again, you can imagine that sort of the 3 different phases. I've moved from sort of the untracked phase to the staged phase. Right? It doesn't see any difference because I've already staged that. I've set it up. So it's looking for untracked changes and the latest commit. That's where the differences are being found. You can type git diff -- staged. And what that's going to do is that's going to give me the difference between all the files that I've got that are staged for commit and haven't been committed yet and my last commit.
I want to.
Sure.
I'm not used to working in this paradigm, so I was wondering if you like do do you add something sometimes and then change it again and then add it again and then commit, or what's going on? I mean, I'm not really sure if I understand everything about how add's being used because I don't normally do that.
Sure. No, so the general practice that I do is I have a files that I'm working on, and I will make those changes, and I won't add the files until right before I commit.
Okay.
That's my own personal way. I don't know if anyone else wants to chime in with
So
their
I think,
workflows.
well, I think you're, like, most other version control systems I've seen, and I'm guessing this is the paradigm that you're coming from, is that, like, when you commit, it takes a snapshot of every file that you are ever tracking. And so there's no reason to add anything to your staging area because it's just recording everything. Git tries to be a little more careful about exactly what's being changed and only saving what you want to save. And so that's why it has this extra step of the staging area. So if you have, let's say, like there's a bug somewhere in your code, maybe you're doing integer revision and you don't want to, and it's in 3 different files. It may make sense for you to change all 3 files and then save those 3 files, but you don't want to save all of the other files in your repository. It's just you want to say that these 3 files changed and I'm going to commit and save this change I made. And so you can add those 3 files to your staging area, and then you can commit them all together and save kind of those changes together, almost like it's like a grouping. And so that's, when you're just doing 1 file at a time, it does feel very repetitive because you're not really using that feature. But and then you might want to do what Ted was talking about with the combining the 2 commands into 1. I guess the developers have recognized that that is sometimes very convenient. I haven't moved to that yet. I still add and then I commit and then I add and then I commit.
In the past I've recognized the need for grouping a little bit with other repositories that with other configuration management tools that I didn't have, so that might be a way to use this.
And generally, I don't know, for me, I try and add and commit in sequence because I don't want to be in a situation where I've made changes and then like after I added something, I made changes and then I think I'm saving those changes and I'm not. So I always, before I commit, add just to make extra sure that I'm really committing the version that I think I'm committing, that I haven't previously staged something and then decided to go off and do something else and then made some changes, but those changes aren't in the staging area. It's an older version of the file that's in the staging area.
Yeah, I often do that. So if maybe I'm working on 10 different files, but it's 1 in the morning and I want to go to sleep, but I'm not quite, so I've reached sort of a good stopping point for, say, half of them. I might just add half of those files. So that I really like the use case of being able to just group some of your files together and being able to add those. But yeah, you always have to go through that add commit. And I'll show you right now actually how to do that all in one line. So to do that, I'm just going to have to commit this change. So I'm just going to quickly So I just made a quick change to mars.txt. I just checked the status. I actually always, and maybe it seems like I'm just repetitively checking the status, but I actually check the status all the time. I do this all the time. So I'm not just doing it as an exercise. It's actually what I do because I always forget where all of the files, the different files are in what phase of, the sort of, stage, untracked, ready to be committed we're at. So I'm definitely doing this all the time. If I want to now just make changes, sorry, I want to commit and add in one step because I said, okay, I see Mars, it's ready to go. I don't want to type git add mars.txt, git commit, right, my message. So I can type git commit and the flag A for automatically add. And then I'm just going to type M because I want to leave a message. And I'll give my informative message. Added my commentary about skiing. And boom, it just made my commit. So
How does it know which file? Does it?
it's going to commit. So if you do that, it's going to commit and add everything that's untracked.
So it
No.
Sorry, everything that's modified. Thank you. Yeah, that's actually an extra step we've sort of glossed over in the sort of the Git. So there's, for untracked files, there's two different ways to, sorry, for modified files, there's two different ways, right? So there's staged, ready to be committed, and there's untracked and unstaged, sorry, there's tracked and tracked files and untracked files. They can both be not staged for commits, which would be, I've added a new file and I haven't typed git add for the first time. Once I type git add for the first time, it's going to start tracking those changes and we enter into that 3 different phases diagram. But you have to type git add for the first time on a file. So for instance, if I had if I had a totally new file and I typed git commit -am, it wouldn't have worked because it doesn't even know that it should be tracking this file. Versus this is a modified file that needs to be staged.
That's good.
So is a use case for this that you're working on multiple bug fixes and you've changed some files for a particular bug fix, and so you really just want to add those, and so doing a commit -a would capture all of the changes you've made, and that's really not what you want. You want to only do commit adds so that you only do the ones that are for this particular bug fix.
So if I was doing one particular bug fix and it was just on a certain subset of files, but I had lots of files that were also modified, I would probably use git add actually first. I wouldn't use this because I would type git add.
Oh, no, I'm saying you wouldn't want to do this.
No, yeah,
Because
exactly.
You don't want to.
You wouldn't want to do
You don't
this.
want to commit everything. You only want to do the subset that are for a particular bug fix.
Yeah.
So git add gives you that control.
Yeah. This is generally what I do if I'm just, and I personally tend to work sequentially on bugs, so I'm always saying, I'm going to do this bug, commit it, this bug, commit it, this bug, commit it. I'm usually not.
Some bugs you just
I'm-
have to work at across multiple.
I'm sure. Nothing I work on is that complicated, personally. But I know that's definitely a use case you would have. And yeah, you would not want to do this because it's going to commit and add everything that's modified.
I'm just trying to see why having that separate add step is powerful.
Yeah.
And that would be a use case where you
Definitely.
have flexibility.
I mean, this is probably something I do like 80% of the time, personally, just sort of as a sort of convenience. So we've covered a lot of ground, and I want to sort of bring us back to have a chance to work on this a little bit more. So we have another exercise that I'd like to sort of walk us through, which is just amending our Jupyter file. We're going to add some lines, view the changes, commit those changes, and if you guys want, there's a couple bonus sections here. So you can make another change and then try committing without adding, because a couple people asked about that. What happens? I mean, your computer doesn't blow up, so nothing really bad will happen. View changes, or try committing without the M and see how that works with opening up your text editor. And so if you guys could throw up some green stickies when you're finished with that, or red stickies if you need a hand.
Just showing what you're trying to get at.
Yeah.
Doing it in their own way.
Yeah.
That
So
works magically
I know.
every time.
I know. It's like,
You
All right.
guys are impressive. Like, we're trying to get something that doesn't work, and
Yes.
everyone's modifying it in the right way that it works.
I will say what that sort of example was meant to show. So I made some changes to Jupyter. And now I'm going to type git commit. There we go. So if I just type git commit, it says changes not staged for commit, no changes to commit.
Okay.
So that's if you just try and commit when you just type, yeah, so the difference that people are running into that you're seeing is when you type git commit, it's going to commit all the changes that are staged. It's saying, hey, I want to commit all the changes. You can, which I think is, so a couple folks did git commit -a. That's going to work fine, because what that'll do is that's going to add all the files and then commit them.
That's what I,
That's a bad commit message. See, I'm slipping into my... That's also going to work. But let me see if this will work. I actually don't know if this will work. So what I've done, by the way, is I just added a new file. And now this is totally untracked. I haven't run git add on it. Let's see what happens when I do this. Yeah. So do you guys see what happened here? So your method of saying git commit the file name and my message works because that file has already been added, right? So even though it hasn't technically been staged, the file is at least being tracked by git. Here, I just added a new file just really quickly, venus.txt, and it's totally untracked. Then I just like, all right, I want to commit venus.txt. So I run my commit message, git commit venus.txt, add my message, and I get this error, right? Which is venus.txt did not match any files that are known, right? Because until I do that first add and make my file tracked, Git is never going to know about it, essentially. Git is totally ignorant of it. So you'll definitely, no matter what you do, you have to do that first add to get the file to be tracked. So what I want to move on to now is, get rid of Venus here, is exploring the history a little bit. So the real power of Git, right, is this ability to roll back different changes, to reset your work if you are going through and you realize, oh wow, the way that I totally screwed up here and I want to revert back to an old version of my file. That's really what we want to do. You want to be able to explore the different versions of your files. And so what you can think of is you can think of your Git as your repository. Each commit is essentially sort of a pointer back to an old version. And we call the most recent commit that you've made, that's called the head, right? So you can sort of imagine it's sort of like a sort of caterpillar with like lots of sort of links, right, between its thorax. It's kind of pointing back, and sort of the head is the most recent commit. So if I want to say, look at the difference between different versions of sort of before, there's a little notation that we use. So git diff head, it's generally in capital letters. So the tilde one, this is just a shorthand for saying I want to look back one version back from my most recent commit. Oh, because I actually need to make a change file. That would be helpful.
do we need to say like two different, maybe tilde1 and maybe,
Do you have to,
maybe say both, first just say head and then say head tilde1?
well, I needed to make some changes because I realized I got ahead of myself and I hadn't made changes first. So this is what I'm going to ask for now is just, this is a way sort of explicitly of asking for, I want the difference between my current version of the file and the most recent version of my most recent commit. Oops. Sorry? The earlier thing, well, it's different because I'm explicitly saying what I want to take the difference from. So yeah, effectively, right, I'm getting, you can see the difference here.
It looks the same.
Yep. No, it does. But I'll cover that in like one second. So what I'm doing here is I'm just saying, here I'm saying explicitly I want to go one back from the head. If I want to go back, say 2, right, tilde 2. So now I'm going to go back 2 commits. Do you see the difference now? Right, so by adding that head tilde 2, I'm asking for the difference between Mars and my current version, and then 2 back.
But you ought to be able to look at the differences between tilde1 and tilde2 without having to make a change. And I don't know how to do
That's, what we can do is we'll cover, should be able to make something like that. So you can do that.
Do you want to show?
Yeah, I went too fast. So you can type git diff. I'm getting a little slightly ahead of myself, but so I just want to bring us back to the same page so we all sort of know where I'm at. So I just added this line, the mountains are big enough. This is the line that I just added. And I haven't tracked these, I haven't committed these changes. So if I do diff head tilde 2, so I'm going to go back 2 commits. That's going to take the difference between the changes I made 2 commits ago and my current version. And so you can see, not only is this new line, but again, you can sort of think, I've committed after every line here. So when I look between my current version and 2 versions ago, which is what I'm saying with head tilde 2, you can see I've got 2 lines that I've changed.
But I mean, you shouldn't have to just make a change to the current version to be able to diff.
No, you're right, you don't. So yeah, so you want to see the difference between, say, the most recent commit that I've made and then 2 commits ago. I can type head git diff head tilde 2 head tilde 1 mars.txt. So now I'm saying I want the difference between these 2 right here for mars.txt. If you type that line that I had, if the mountains are big enough, that's gone, right? Because I haven't committed. That's an untracked change. So now you're getting the difference between those 2 commits.
But I didn't make a change. I didn't make a change.
Mm-hmm.
And because I didn't make a change, it's not letting me do that diff.
What if you tried the tilde 1, tilde 2?
Yeah.
And what error message are you?
It just shows no differences between tilde1 and tilde2 because I didn't add a change.
Oh, yeah. Well, that could be the reason. So you could try also going back to, but say head tilde 3. And this will go back any number of versions, so I can tell the difference between head tilde 1, my most recent commit, and head tilde 2.
Got it.
Right? If I go back 4, you can see again I've just added these lines sequentially.
You just have to go back to one where you actually make changes in that file. So that might not be
Yes.
the file.
That's what we were saying.
Okay.
Yes. Okay, here we go. So so yeah, let me get back to where I was at. All right, so if I just type head tilde 1 and head tilde 5, I've made changes to 2 different files, and I'm not specifying a file. So it's giving me the changes between those, and it's giving me the changes to all the files, right? So Jupiter is on the top, and Mars is down here. And if I say something like this, between head 1 and 2, Jupiter.txt, right? I didn't make any changes, right? It's been a while since I've made any changes to Jupiter.txt. So if I ask for the diff between those two different commits on that file, I get nothing, because I haven't made any changes.
I see.
Right. So that's one way that you can go back. This is sort of a convenient shorthand if you're like, oh, I want to know like between the last couple of things I've done. If you want to go way back in your history, like quickly this becomes pretty cumbersome. So we're going to return to our git log command. So here's my whole history. And let's say I want to know the difference between my most recent commit and, actually between my current version that I've got and my file. So the way you can do this is with the commit hash here. So you can copy and paste this whole thing if you want. That's quite long and mildly inconvenient. So Git's pretty good at just recognizing the first little part of the hash. I don't know what the minimum is. Do you
I
know?
think the recommended is 7 or 5.
Do you know, Matt, what the sort of,
I don't know if there is a minimum.
yeah.
So these hashes are so big because if every person in this room is all working on their computer and then it wants to, and is making a bunch of commit messages, it wants to make a unique identifier to every change each person makes so that when we all try and combine our changes, nothing has the same hash, nothing has the same identifier. Every identifier is unique. So you have this, and you could be working on a project for years and have 20 people working on a project for years. So you have this really long string, but to uniquely identify like your part, generally you don't need the whole thing. So
Yeah.
depending on your history, you could probably get away with fewer or more. I'm pretty sure the recommendation is 5 or 7.
They tell you that I don't think there is a minimum, but if you pick perhaps 7, like that's plenty to guarantee it'll be unique.
Yeah, that's usually what I do. I usually grab the first 7. Or what looks like the first 7 quickly. I don't count. That's not quite worth it. So I'm going to go back. So we're going to just go back, get that very first commit from our log, and then type git diff the hash reference number and mars.txt. And so what you can see is all the lines that I've added since that first commit. So does that make sense to everyone?
Can you do that one again?
Yeah, sure.
You're having a hard time grabbing out of the.
Sure. So git log, and then I scroll down to get the first one. And then I'm copying and pasting the first few characters of
How are people
this.
doing with copying and pasting who are on Windows machines? Yeah,
Go
Oh.
up into the upper left-hand corner and click on the little git thing, and then go down to edit, and then mark. And then you can copy and paste out of that window if you're using your git. You can't do that?
I'm stopping it. Does anyone know isn't there a special paste command for pasting into the git bash on Windows?
Well, it's not pasting, you can't even select it.
It won't
can't
let you even select, and that's why if you do that, you
Right,
get
do the
into mark
mark.
mode, and then you can copy.
So I clicked up here, and so mark, and then it lets you select.
Okay, awesome. Okay, who's having issues?
Yeah.
And then when you go there,
Oh, okay, awesome.
All right. So is that sort of clear to everyone using the hashes?
Well, we need to now do it.
Right. Okay.
We can select it.
So is everybody who has a Windows machine, is everybody able to select the hash? Yes?
Oh,
Q. Yeah, Q should get you out. So now we're going to type git diff our hash and then mars.txt. So that's going to take the difference between the current version that I have and my very first commit. So this is letting me see all the changes I've made to the mars.txt. Right, so you can see all the lines that I've added as we've gone through. Yes?
And if you didn't include the mars.txt, it'd be telling you the difference in every tracked file between
Yeah,
that commit and current state.
exactly. So here you can see I've got all the changes for Jupiter and all the changes for Mars. Right, and so the same way that we were able to, essentially the head tilde 1, head tilde 2, go moving back from the head, those are essentially substitutes for hashes. So the same way that I sort of did this command right here, diff head tilde 2, head tilde 1, I can get the same thing from the log. So say I want to know my first commit and then this commit where I added some ideas about mummies. I can grab this hash. I can add my 2 hashes. That's probably a little too fast. I can add my 2 hashes, so I've got gif diff, my first commit, my commit about mummies, and for mars.txt. And that'll output this, right? So again, you can see, if you recall sort of where the file was at, those those most recent changes I've made, those aren't even showing up, right? Because it's just showing the difference between my first version and then a version somewhere in the middle.
I get the idea that hash, that there would be a hash associated with several files if we made changes to several files. We haven't done that yet, right?
We haven't done that. You may have with the Jupyter, but yeah, a hash is associated with a commit, not necessarily a set of files.
Okay.
So if in that particular commit you modified 10 files,
Okay.
right, that hash is associated with the commit for those 10 files. But yeah, it's not a specific file necessarily. You can extract the differences for just one file, right? So if you have your commit and there were 10 files that were part of that commit, but you just want to know the difference to that one particular file, that's when you add the file. So git diff, my 2 different hashes, then the file name, that extracts just those differences for that one file. Otherwise, you'll get the differences for all 10 of them if you don't add that file.
Can you specify?
Oh, sorry. No, you can go ahead.
Oh, I think that's what you just did. I wasn't thinking.
Oh, yeah, I've specified with these with the different hashes, yeah. So again, the head tilde 1, head tilde 5, whatever that happens to be, that's a shorthand way of moving back just sort of quickly. If you're like me, you probably will rapidly forget anything you did more than like 2 or 3 commits ago. And so essentially going through the log, looking at your commit messages, looking at the timestamps, whatever sort of is your cue to know what you want to find differences for, then getting that hash. But the log is going to hold a record of all those changes for you to refer back to. So now we're just going to come to probably the most, I think, powerful thing about Git, or one of the most powerful things, which is the ability to sort of move back through your history. So say, we've got this sequential record of all the changes that we've made. But say I want to go back to a particular thing because, you know what? I'm really not happy with my commentary about skiing. That doesn't really, like, I've got this file and I've added a lot of thoughts about monsters on Mars. But I haven't really, the skiing thing it's just not really congruous with the rest of the train of thought. This is sort of the equivalent of I'm sort of coding through and maybe I implement something and I'm just not particularly happy with that feature. One thing we could do is essentially roll back all of those changes. And there's a way that we can do that, which is with a command called checkout. So what I'm going to do is I'm going to grab my hash here. Now it's important that you need to grab the commit before the changes, right? So if I want to get rid of my commentary on skiing, I need to go back to the commit that was before that skiing commentary, right? So I don't want to if I want to roll back to before added the commentary about skiing, I don't want this hash. I want this hash here. And I think I've got some unstaged commits here, so I do. So I'm actually glad I checked status, because before I even do this, I want to make sure that I'm up on all my commits. I don't have anything just ready to go, so I'm just going to quickly commit this. Boy. Okay. I actually totally forgot what I added. So now that I've seen what I've added, I can add a meaningful commit message. Okay. So now I can just check. I can make sure that my status is clean. And what I want to do now is check out this. I want to go back. And so we're going to basically check out this file, the Mars file, in an old version. So git checkout. I'm going to give the hash and mars.txt. And so what this is going to do is it's going to keep, imagine you can have lots of files. By specifying mars.txt, I'm saying I want to go back to this particular version of the mars.txt file, right? If you were to say not add the mars.txt, it's going to move the whole repository back. I don't necessarily want to do that. I just want this one file. Okay, so now you type that, and it looks like nothing's happened. But as you can see, when I output mars.txt, all of my commentary about skiing and mountains that really isn't congruous with, all the monsters commentary I had written is gone, right? Because I've rolled back. And so this is pretty interesting. If we type git status, you can see that this file is staged and ready to go. And so by checking out, it's basically taken this old version and moved it to this, moved the head to this particular area. So the head is always sort of the pointer to the most recent version. So it's changed what's pointing at head right now. So if we want to actually, let's say I'm happy with these particular changes, I can type git commit. I'm going to add my message here. I'll say something like moved skiing commentary. Okay, so the one file changed, 2 deletions. So I guess now my question before we type git log is, what do you guys think happened here? Is there a new commit? Do I have my whole history and then I have just, basically I could go back to those mountain changes if I wanted to? Or are those changes just lost because I've rolled back? You think the whole history is preserved?
Yeah.
Everything's whole history is preserved? Let's see. Yeah, exactly. So now what I've done is I've preserved the whole history. So using this git checkout of a particular file method, what that does is it allows me to basically move the head and point it to an old version of the, an older sort of version of the file, an older commit. If I'm happy with those changes, I've looked at them, I'm just like, hey, I'm pretty happy with my deleting this commentary on skiing and mountains from my text about Mars, then I can commit those changes, and then boom, remove skiing commentary. And in fact, if I was, say, I could even do this, right? What if I'm like, oh, that actually was a bad decision. I really do love skiing, and, I want it back. I could type something like checkout head ~2 mars.txt. And now I've got my skiing commentary back. And again, same thing, it's staged. Yeah.
So you go check out.
Yeah, ~2, ~1. Right, so what that's doing is that's just letting me sort of shorthand. I'm like, oh, maybe, I didn't necessarily want to go back. I chose to go back 2 changes. If you want to go back to the version right before the last commit, it should be head ~1. And make that commit. So again, you can see I'm preserving my whole history throughout this repository. Now there's actually multiple ways that you can roll back changes in a file or in a repository. This is probably the most useful way because it's allowing you to basically move back to that snapshot. If you're happy with those changes, commit them, and then move on, and that preserves the whole history. There is a way to essentially like delete commits, but that's kind of dark magic, so I'm not going to talk about it. But I'll just let you know that it is out there. You know, there's lots of debates on Stack Overflow about how best to do that.
How about if you go back and you don't want it? So you went back and you looked at whatever your prior version, prior file was, and you didn't want it?
Yeah, good question. So I'll do that. So I'll just say, I'll go way back to my first commit. So what I can do now, if I want to go back, oops, is so git checkout head. So head is sort of the most recent snapshot you've got, right? So again, just sort of walk you through that. I want to go back, I'm like, oh, I'm not happy with anything I've written, I'm just going to go back to my first commit, which is this particular hash. It's git checkout mars.txt, and then, right, I just do output. So I just have the first line. I look at it, I'm like, you know what? I actually don't want to revert back to all of that. Like I am happy with my work. I do git checkout head. That's going to bring me to the most recent snapshot that I've got for mars.txt. And now I've got everything back. So does that make sense about how to move between different commits? Right, so checkout, so git checkout and then the hash or the head ~123, basically what that's letting you do is it's letting you totally explore and move around the versions. If I didn't include mars.txt, then I would get the whole thing back, right? I would move, so any changes I made to Jupyter or whatnot would also show up there, all the files. Right, so Git gives you this flexibility to move back and forth between single files or groups of files and the entire repository, which is super useful because in any given commit, I'm probably changing more than one file. But if I want to roll back versions, I may not want to roll back every file, right? So Git's letting you sort of have this incredible flexibility to explore the version history of every single file. So what I want to do now is sort of break for some exercises here. So this is definitely an important concept to have down. So what I want all of us to do is to, since we've either an existing file or our Jupyter or whatever file you've been working on, to make some changes, commit those changes, and then try rolling back. And just spend some time exploring how to move between different versions of a file with a checkout command, right? So, try checking it out, and then making a commit and sort of rolling that forward. Try checking out a version of a file, of your Jupyter file, to the very first commit that you made for it, and then maybe deciding, like I did, just to check out the head because you want to get those changes back. Or sorry, you aren't happy with going back to that first version. And so if you guys are all set, put up some green stickies, and if you need a hand, put up red stickies. All right, so is everybody able to successfully roll back some changes? All right. Awesome. So does that make sense to everyone, by the way, in terms of how to sort of move around and explore the different versions? This is, probably one of the most useful things about Git is this ability to very easily move around versions without necessarily look at different versions of individual files without necessarily committing to the changes that you make in those even. Right, all right, awesome. So a lot of times, we're going to cover one more little tiny section here before we have a break. So another use case that I certainly encounter a lot with Git is if I'm working on a particular project, I'm collaborating with people, there may be, like this, the most common use case I come up for this is maybe I'm working on a project in R, so I use RStudio, and they have these project files, and maybe I'm collaborating with somebody who doesn't necessarily use that, and I don't want to keep track of certain files. So I don't want to keep track of the collaborating, all right? Or maybe I'm using, say, Jekyll to render things, and I don't want to keep track of the HTML. I just want to keep track of the Markdown, right? There's lots of scenarios where you have files within the repository that you don't want Git to track, right? Sometimes it's just one or two, and I guess the sort of cheap and easy way is just never add them. But there's actually an easier way to do that, because Git's always going to kind of give you a hard time, and that's with an ignore file. And so the standard way of creating this is it's called .gitignore. And every file that you list in .gitignore is going to be ignored by Git. It's pretty straightforward. So I'm going to start. Just look, I've got these two files. So I'm currently tracking these two files, Jupiter and Mars. And maybe I want to add some things. So there's, I'm going to use just touch. I'm going to add a bunch of files. So and I'm going to add a new directory called results. And of course, I didn't actually add the results directory first. Oops. So I'm going to make my directory results. Now we'll go back.
Well, I'm learning a lot.
I'm glad we were close to you learning something. I'll take it.
I'm learning a whole lot.
Yeah, sorry. I totally forgot any other. So I'm going to make this directory results. And touch is just going to create empty files with these file names. And so now if I type git status, you guys can see, right? I have these files that are untracked in this whole directory that's untracked. So if I actually want to ignore the files, again, I can just never add them. That's generally not a good practice to have, because it just sort of clutters up your git statuses and makes everything kind of confusing. So to solve this, there is a file called gitignore. So you don't have this, so just open it in your favorite text editor, gitignore. And then the nice part is that the gitignore file will accept wildcards. So I have all these dat files, right? But I don't, necessarily want them, right? So I'm just going to say ignore star.dat results slash. Now, when we type git status, the only file that's tracked is gitignore. So, I guess my question to everybody is, do you think, should we track gitignore or should we ignore gitignore? Track. Yes, have any thoughts?
Yeah.
Everybody thinks we should track it?
Yeah.
I usually track it. You can ignore it though. Gitignore can ignore itself, right? So a scenario where possibly you would want to ignore gitignore is if maybe I have one sort of set of configuration files in my repository and a collaborator has a different set of configuration files, maybe for their, we use different IDEs or whatever, right? And they're dumping some files in there. Maybe I want to have my own version of gitignore. Although, there's no limit to the things you can dump into gitignore, right? There's no penalty for having things in .gitignore that I don't actually have. So generally speaking, it's good to track gitignore. So I'm going to add it. I'm going to commit it. Right? So here, you have this. Now, if you want to actually, what do you think happens if we add a file that's been ignored? All right, let's find out. Git add a.dat. So Git, again, it's super helpful in terms of letting us know what we maybe want to do. So this is saying, hey, maybe you actually didn't want to add that because it's in your git ignore. So it's not going to default add it. And then it says, if you really want to, if you want to get around this, use -f for force it. So we can technically add it. So you could say git add, I'm not actually going to do this, -f. And so that can add it. That's probably not a great idea if you really don't want to track that file. Sorry, if you really want to add that file, it's probably better to just go into your git ignore and change what your git ignore says. We can also check the status of all our ignored files if we want. With git status ignored. So you can see this could quickly become complicated if I have a file that I'm ignoring and then I actually add it and maybe start committing that file. So now I've forced it to keep track of it, but I've also got it in git ignore, right? That quickly becomes a kind of confusing scenario. But you can technically use git status -- ignored, and that's just going to give you a list of all the files that you've got ignored. So there's one last scenario that I actually probably encounter a lot personally for ignoring files. And that might be, I've got this file, call it Venus.
Just mention the touch command.
Yeah. Oh, we did.
We've seen that before. I don't think we covered it in the show.
Oh, I know, sorry, I said something. But yeah, again, the touch will just create an empty file. So it's there, but it doesn't have anything in it. So now I've got my venus.txt file. I'm just going to add it. I'm going to commit it. Okay. So now I've got this file, but maybe I want to ignore it. I've added it, I've started tracking it, but maybe I'm like, yeah, I really don't need to track that, or maybe I accidentally tracked it in a big commit because I'm me and I'm kind of lazy, so I did like git add -- all, and I added a whole bunch of files that I didn't mean to and committed them. So what I'm going to do is I'm going to edit my git ignore. I'm going to add my Venus file to it. And then I'm also going to see. But yes, I'm going to add my quick line to it. So what happens here? So I've modified the venus.txt file, but I've also added it to git ignore. So what happens when I type git status? What do people think? Will it say anything about Venus, or is it going to ignore it? I heard somebody say ignore it, I think. No, it's still tracking it, right? So this is sort of a tricky situation because I have started tracking Venus, then I've decided I don't want to track it anymore, but it's still showing up, right? So every time, so if I type git add -- all, it's going to add it. If I type git commit, it's going to commit those changes, even though I've asked for it to be ignored. So the way that we can get around this is with this command git rm -- cached venus.txt. So what this is going to do is it's going to remove the file from version control, but it's going to leave it on my hard drive, right? So obviously if I don't want the file at all, I can just type, I can just delete the file and problem solved. But often it's a scenario where I don't want to track it anymore. I've added to git ignore, but I want to keep my local copy of it. Right? So now I've said the two things. This is deleted, this is modified. So what we're going to do is we're going to commit these changes. Ignore. So this is kind of funky, right? Because Git says that I've deleted the file, right? It says delete mode. But Venus is still here. It's right here. In fact, the change I made is still here, right? So what I've done with the git rm dash dash cache is I've deleted it from the Git system, so it's no longer being tracked, right? But those changes are still being saved locally, right? So it's basically just treated now as another file that I'm ignoring. So that's sort of another common use case that I've encountered a lot, where I've accidentally committed something, or I've been working on something, and now I want to sort of remove it from say, the GitHub repo, but I still want to keep my local copy of it in that same directory. This is one way you can do it.
When you get status, is it in untracked?
Nope. Because I added it to git ignore. Yeah. So the last exercise that I think that we should do before we take a break is for all of us to sort of add some files, create a directory, add several files to them, add those to git ignore, and that's sort of our basic exercise. Throw up a green sticky when you guys have completed that. Bonus, you can use some wildcards if you want. And extra bonus that I don't actually have up on the exercise would also be try doing what I just did, which is actually adding accidentally commit a file, then add it to your git ignore, and then take it back out of the Git system. Yeah, that's like double bonus.
So are we creating a directory under the 1035?
Yeah. All right, so we're just going to wrap up. Are there any final questions about any of the stuff I've covered this morning?
How many people feel like they would be comfortable going home and experimenting with this?
All right.
I consider
It's like a 60% bar. All right. Well, there's more too, right? So we'll cover more of it. Just a couple last notes is when you create an entire directory, when you, let's see. So I'm just going to unignore my git ignore. I'm going to unignore my, results directory. So when you see this, it says untracked files, results /. There's a bunch of files in results /, but it's just showing you that this directory and all of its contents are currently untracked. But as soon as I add git results, now it's gone through and it's added each file, right? So just so you know, when that first add for the directory, it's going to just show you the directory and not all the files in it. Once you add it, then you'll be able to see all the files. So I just wanted to sort of point that out to folks. And then just the last note, I'll say sort of a general commentary about Git, which is Git can probably do almost anything you can want it to do, and then 1,000 other things that you don't even know that you may want to do. The stuff that we're covering, and I covered this morning, will probably suffice for like 98% of what you want to do, right? So it's like 2% of the things that Git can do is like 98% of what you want to do, give or take. And then for that last 2%, there's just thousands of commands and flags and all sorts of things that if you were to ask me, I would have no idea. I would have to refer to like the tome of Git commands. So I just let you know that even though Git can sort of seem intimidating because it's so flexible and there's so many commands, it's really just a few basic commands will get you through almost everything that you'll need to do. So don't be intimidated by that flexibility and the depth that it has. Like really, Those
you
few
know-
service things will work.
You now know how to undo anything you do accidentally. So that's a good place to be in.
Yeah, that's the beauty. You can't screw anything up. Like, it's basically impossible to make any mistakes.
Now you're lying.
No, I'm not. You can always go back to a different version. Well, I am lying. There are things you
are
can screw up. Okay, but it's still pretty hard to screw up.
It's at the end.
It may be hard to recover, but it's there somewhere.
Yeah, like git reset dash dash hard.
Okay, you guys, are we ready to get started? Yes, okay. So I just wanted to kind of, before we go any further, give you kind of the explicit situation, because we've been talking about Wolfman. I don't think we've really talked about Dracula, but that's why red was his favorite color. It was Mars. So we have Wolfman and Dracula, and you guys are going to assume these personas at some point in the near future, so that you can collaborate with each other. Because the whole point is they're done with Earth, they're going to go to a different planet in the solar system, and they're trying to figure out which planet to go to. And so that's what all of these files revolve around, is should we go to Mars, should we go to Jupiter, what do we want to bring, stuff like that. So in the, I know this is going to be small, but in the repository for our class that you downloaded yesterday, where you found your last slideshow, there are 2 other slideshows. They all start with slides. One is called Git branching, and then the other is called collaborating using Git. We're going to start with the Git branching one. And that looks like that. Yes, Matt.
These are also accessible via our website.
Oh, yes.
And
Actually, that's even better because I updated to one of them.
I put the links in the website, not the website, in the
Yeah.
If you can get to our website, the link,
And let me.
there's a link from the website to the Etherpad. You remember that? Not the software carpentry website, so like the website we sent you with the,
Oh, I was putting up the Etherpad URL.
yeah, well, there's a link from there, but Azalee's got it up, learning that's really cool.
So that's the Etherpad. No one has asked any questions on the Etherpad today. So I think it's awesome because you've been asking lots of questions to Ted and to all of us, and that's great. If you have something you want to add, feel free. We are still using the Etherpad. People are still looking at it. We're writing down some notes. And then the slides Matt put links to in here. And so this is linking directly to actually what I'm showing you guys. All of this is done online. Okay, so the rest of, until lunchtime, what we're going to spend time looking at, one is branching. And branching is a really cool feature of Git. What it does is it allows you to maintain one version of your code that works, that you know works, and then go off and experiment with 10 different ideas if you want. You can go make as many branches as you want. You can say, I have this really good idea, and then halfway through that idea, I realize there's a bug I need to fix, and I can go fix that bug, and then I can, combine that bug fix into this new crazy idea I'm experimenting with, and the whole time my collaborators have a version that works, and I have a version that works. I used to do calibration work at Space Telescope Science Institute for the Hubble Space Telescope, and we have to deliver new reference files every month. And so you'd be off trying to develop new code to maybe make this process easier, and then you'd get new data, and you'd have to make those reference files, and you'd have to deliver them. And so we moved everyone from no version control to a form of Git version control, and that was really, it made everything so much better. It makes transferring projects easier. So we're going to talk about branching and then how to actually combine your branches back together. And then the final thing we're going to do is we're going to actually move on to working with each other. How do you collaborate either with yourself across different machines? This is something I encountered a lot where I was like emailing myself files and then I couldn't remember whether my most recent version was the one I emailed to myself or the one I downloaded, and then which machine had I downloaded it onto. And then you can't just sort by modification date because they're on different machines, and then so that was a big issue. Like, just collaborating with myself was a big thing that Git helped for me. And then actually collaborating with others, being able to say, this is the code I used for this analysis. I'm working with someone where we have a bunch of different supernovas that we're observing, supernovae, which are exploding stars. And we use the same code. So I wrote the initial pipeline code, and then I shared my repository with him, and then he then used it to analyze other pieces of code. And that was really useful. And then he could, when he had made changes for maybe, you know, this one special case supernovae, then we combined them back to us. I was able to incorporate them back into my version. And so this is, I think, the power of Git. You've learned how to use it. You're tracking your history. That's great. This is kind of how to further explore that. So the idea of branching is that you start with your default branch, which is just called the master branch by default. And that, if you looked right now, everyone's on the master branch. And then you come up with this new idea, and you create a new branch. And so it could be, this could be your bug fix, this could be your, you know, brilliant new way where you're totally redesigning your code, anything you want. And then you can switch to that branch, and you can start modifying your code on that branch, make no changes on your master branch, and then in the end you can combine them. And that's kind of what we'll do next. So what we're gonna do is we wanna look at our Mars file, and we're going to make it into a pro-con list instead of just, you know, listing ideas. Okay, so now is the tricky part. Okay, how is this for size? Terminal, too small. Better? Still too small. Matt, you were the farthest. I can't even tell if it's working. Yeah? Better? Okay, good. If you notice, many of us have glasses. I wear contacts, so I can relate to not being able to see. One more? How's that? Okay, so the way to create a branch is just to type git branch, and then whatever you want the name of your branch to be. So I'm going to call this pro-con list. So then the next thing to look at is to say git branch. Now, okay, I have to say, this is like one of my least favorite syntaxes of Git is how they do branches. So git branch, name of the new branch, makes a branch. If you just type git branch with nothing after it, it tells you what branches there are, and then it highlights which one you're on. And so this star tells you that you're on, that's the branch you're on, and then because we have that fancy color coding on, it's also green. So we're on the master branch. So even though we created this new branch, it didn't automatically put us on that branch. To switch branches, you have to type git checkout and then the branch you want to switch to. And it will actually tell you this useful, I'm switching to this branch. Okay, let me see. Post-it, green post-its when you have switched to a new branch. I see two. I'm in my planets directory. Matt, do you want to grab? Yes.
So if we had left our master branch in a poor situation, and then that would be a bad time to branch.
Yeah, so it's going to create a copy of when you last committed. I think it's going to branch from your commit. So it's not any modifications that you've made. If you're like halfway through modifying but you haven't committed them, those changes aren't going to get ported over. So what we can do here, let's actually go, so we'll practice our git checkout. Let's go back to master. And let's do a git status. This is probably always a good idea. So I can see I've modified Mars. I don't remember how I modified that. So let me diff it. I always like to diff with the file name because as you get more and more files, you get more and more, you often get like a bunch of differences, and I like to know exactly what I'm doing. Okay, so I added a note about mountains. So I'm just gonna, it is a good practice to kind of clean up where you are before you switch branches. So let's add Mars and commit it. If you are in a state where when you type git status, your repository is clean, that's great. Okay, so now let's go back to our pro-con list branch. Okay, and now let's actually look at Mars. Okay, so you can see that I branched before I'd added that note about mountains. So on my branch, it doesn't have that change because I hadn't committed that change yet. So this is the first example. My branches now look different because this one has notes about skiing, but not notes about how awesome the mountains are going to be on Mars. Whereas my master branch has that note about the mountains on Mars. So what we can do is let's okay, let's add a note here. Does anyone have anything they think is incredibly cool about Mars? No? Martians, okay. So do we consider, actually, so we can say there could be Martians. Let's save that. We'll add it. We're adding a note about the Martians. Okay, but now what we really want to do is make a pro-con list. So let's go back into Mars and let's edit this file, right? We're radically changing the file. So I'm going to say pro-con. I would say everything is my favorite color is a pro. A con is that it's cold and dry. The 2 moons are definitely a con. What else do I have here? No humidity is a pro for the mummy. I guess we're considering bringing a 3rd friend along. And then pro is great skiing. So I've made my pro-con list. I'm going to get rid of the rest of this. Oh, we should add Martians to our cons because I don't know, if I'm settling somewhere, I'd prefer for it to be uninhabited. Although maybe you can make friends. I don't know, pro or con? Pro? Okay. So Mars is looking pretty good. Martians. Okay, so I'm just making a pro-con list. If your pro-con list looks a little different, you included different things, you don't have to include everything. But the point is that even though my file says the same thing, I'm changing the whole format. Okay, and then let's save it. So I'm going to save it and close it. And then let's add it. And actually, like Ted was saying, you want to leave yourself great commit messages. One of my favorite lines I read, I'm trying to remember where I read this, but what they said was your commit messages are notes to your future self, and your past self doesn't answer email. So you are trying to tell yourself in 6 months, in a year, in 2 years, what you were thinking. So as detailed as possible. This is why sometimes, very often I use -m, but if I've made some significant changes, if I've made multiple changes and maybe I didn't commit them as incrementally as I wanted, I will write, you know, a couple paragraphs or a bulleted point commit message. Okay, so now if I look at Mars on this branch, I have my pro-con list. And if I double check with branch I'm on my pro-con list branch. If I go to my master branch and I look at my file, it's still in its old format. So here's where these two things look very different, but they started from the same point, and ultimately we can combine them back when we're ready. Are there any questions on this so far?
So you're currently on your master, and what did you say that you went back to your master?
I went back to the master branch, and then so that was this git checkout master right here.
Okay.
And then I said cat Mars.
Okay, and that doesn't have the, okay, and that won't have the line that's associated with the branch.
Right. Okay, so for your first exercise, you guys should all be on the master branch at this point. Stay on the master branch. These exercises, there's going to be a lot of words, but it's just descriptive directions. So go ahead, work on this. Take your green stickies down, put them up when you're done. Ask us questions as you're going through. You guys, I'm going to start going over this exercise. If you're still working, you can keep working, or you can kind of follow along, and then when we get to the point that you're at, you can keep going. Okay, so the first thing, it says make sure you're on the master branch. I'm going to type git branch to double check that I am, here, let me move this. I am in fact on the master branch. Then I'm going to make a new file called packing list. And I can start putting an item on it. Maybe I want to make sure I bring my cape. Okay, so then if I look at my file system here, there's packing system, or there's packing list. If I looked in my file system via, well, the Finder or whatever you have, packing list is here as well. So I do see it in my file system. Switch branches, git check out, pro-con list. When I then look at, I do still see packing list. When I look in my Finder system, I do still see my packing list there. So when a file is untracked, when Git doesn't know where it belongs, it's just visible everywhere because it's not really part of your Git system yet. Okay, so the next thing is to make sure you're on the master branch. So let's check out master again. And add our packing list. Commit it. Then let's check out our file system again. When I look here, I see it. When I look in my Finder, I also see it. If I switch branches to my pro-con list, I check that out. When I look, I no longer see the file. And it's even interfacing with my whole Finder system so it's not visible. This is because you've now told Git exactly which branch that belongs on, and you've said it belongs here, but not here yet. And so now that it knows where it belongs, it can assign it to whatever you're viewing. If you're viewing that branch, it's there, and if you're not viewing that branch, it's not there. So if we go back to master, we'll see it again. Are there any questions on that? That was startling to me when I first saw it. So I always think it's important to cover it.
I didn't get it.
So
I better not customize a class to this. Go ahead.
okay, if you want someone, maybe during the next exercise. Okay, so now let's go back to master. Git checkout master. And we're going to create a new branch called, so this is for Wolfman's packing list. Wolfman packing. And then I want to switch to that branch. And then I'm going to add an item to the packing list. So, I actually really struggled to figure out what Wolfman wants to bring to Mars, but maybe he wants to bring a good book. We'll save that and exit, and then add. Okay, so then, now if I look at my packing list, I see that there's a good book on it. If I go back to my master branch, and I look at my packing list, it's just the cape still, because I branched from the cape, and then I modified one branch, but I didn't ever modify my master branch. Okay, are there any questions? Okay, let's move on. So, now, how do we now combine back our files? So this is called merging. Merging is the simplest way to do this. There are other ways to combine your histories. And this is the basic picture of what merging looks like. You've made your branch. You, let's say, add one item to one list. You could add another item to another list. And then you get to a point where you want to combine the files. So, this orange is a combination of the red and the yellow. So here I'm merging my yellow branch into my red branch. The yellow branch continues to exist, and it doesn't know anything about the changes I've made to the red branch. It just can kind of keep on going along until I decide to get rid of it. The red branch now has the combined changes that I made to the red branch and to the yellow branch, and then this can continue parallel to the yellow branch for as long as you want. Are there any questions about that? Okay, so so there are different ways that merging can happen, and we're going to look at both of those cases. The first way is that you can merge with no conflict. And what that means is that you modified one line of a file on one branch and either a different file or a different line of the other file on the other branch. And when you combine them, Git says, I'm going to take the line you modified from this file and then the other line you modified, and I'm going to combine them together because you didn't make any changes that conflict with each other. If you modify the same line of the file on two different branches and then try and combine them, it says, wait a minute, I don't know which change you really want to keep and which one you want to throw away. And then you have to actually manually intervene. And so we'll look at that example second. That's called merging with a conflict. So just starting off merging without a conflict, we're actually going to skip ahead and do the exercise if you're following along with the slides. Okay, so let's check which branch we're on. So we're on the master branch, and just to remind ourselves, oh, no, that's not the file I want to look at. let's look at our packing list. We have just the cape. If I go to my Wolfman packing, and I look at my packing list, it has the good book and the cape. Okay, so what I want to do is I want to merge my Wolfman packing list into my master list. So I'm going to go back to master. When I look at my branch, it says I'm on the master branch. This is always a good thing to make sure you're where you think you are before you start merging things. And then I'm going to type git merge, and then the branch that I want to merge into the branch that I'm on. So
How do you list of branches?
you type git branch with nothing after it.
Describe what you're gonna merge again, just one more time.
So I'm going to merge my Wolfman packing branch into my master branch so that when I look at my master branch, it has both the cape and the good book on it. Okay, so git merge and then Wolfman packing. So now this is telling me that I've added a line to my packing list and that was the one file changed. Now if I look at my packing list, it now has the book on it. So this is there was no conflict. When you get a conflict, it's very explicit. I think conflict is in all capital letters, says you have to resolve your changes. So this is kind of the seamless, easy way to merge things. And again, the syntax is just you go to the branch that you want to merge into. So in our picture, that was our red branch. Our red branch is our master branch. And then the branch that we wanted to merge into that branch is our Wolfman packing branch. That's the yellow branch. And so we merged our yellow branch into our red branch. And now they actually look the same. If I look, or they look this, at least this file looks the same on both of them.
And of course, I got the conflicts whenever I did the git merge. I was in master and I did the git merge Wolfman packing.
Okay, then I'm going to say, hold on one second because we're about to learn how to resolve conflicts. Okay, so are there any questions on this merge so far? No. Okay.
With any files that are different, we'll go ahead and merge. Because you didn't make it.
Yes, you're merging the whole branch. You're not merging a single file. Okay, so now what we're going to do is... Actually, I think... Okay. Let's go back to... Let's go back to our... okay, which branch are we on first? Okay, we're on the master branch. Let's look at Mars, our Mars file, and instead of saying everything's my favorite color, let's say everything, let's be a little bit more explicit and say everything is red. And then we're just going to save that. Oops. And exit. And then we'll add it and commit it. Okay. So now if you remember, on our pro-con list, we'd already modified our Mars file to be a pro-con list. And now we've modified something here in our Mars file, and now we're going to try and combine them. So again, before we combine, we want to check which branch we're on. We type git branch. We're on the master branch. That's great. This also allows us to make sure we know the name of the branch we want to merge into. So now I can type git merge pro-con list. And you get a message that looks like this. It says you it said I was trying to auto merge it and I ran into a conflict. I can't automatically merge it, so fix the conflicts and then we can get on our way. So what does it mean to actually have a conflict? If you go into Nano and you look at mars.txt, you'll see something that looks like this. And here what it's done is it said, one of your files looks like this. You have this thing that says head, and all the way down to the dashed line is what that file looks like. Then everything that's below the dashed line, up through this arrow that says pro-con list, that's what's in the other file. What your job is to make this file look however you want it to look. So you can keep whichever lines from one file you want to keep, you can keep the other lines from the other file, get rid of the head and the dashed lines and the pro-con list that it added in, and then save it. So I'm going to say, I really want that pro-con list. That's what I meant to do. And maybe I'll just finally change favorite color to be red. Okay, so that's one change. I'll combine my changes and say everything's red here. And then I want to get rid of this line. So I'm going to save that now and exit. Now if I type git status, it tells me that I have these merged and modified. So I want to now add Mars and say, okay, I fixed this. It now looks the way I want it to look. And then I'm going to commit it. If you just type git commit, it gives you this automatic message that says you're merging these branches. If you want to append that, it gives you the option to say, you could just keep the default message, or you could say, I'm merging these branches, specifying color, and making pro-con list. You can be more specific if you want. If all you care is that it preserves the history that you merged these two branches, that's fine. This is just like the commit message when you don't use the -m. And then you just save it, use the default file name it gives you, and exit. And now it tells you that it actually was able to merge it.
So when I had the conflicts, I did git diff, and that was kind of nice. And it showed me specifically on that file name. I did a git diff packing list, and it showed what was on the head, and it showed what was in Wolfman packing. And I still haven't resolved them.
Okay, well now you know how.
Well, at least I see the differences. I think you're in some kind of, you're in Nano, and you said,
so if you look at that file in Nano, you will see that's a very similar view.
Okay, cool. All right. Yeah.
Okay, so the last thing I want to show you is that if you want, when you're done with a branch, sometimes you don't want to keep your branches around infinitely. Maybe you have a little bug fix, you make that fix, you merge it in, and you don't ever need that branch again. What you can do is you can actually delete that branch. Let's first make sure we're on the branch we want to be on, git branch, and I can say git branch -D, and then I can get rid of my pro-con list. One warning I want to make is that once you delete a branch, you can't, you're getting rid of that history. You're kind of unlinking it. Do you still need help? Can someone, your sticky went down.
I just deleted the branch and then I just...
Okay.
Yeah.
Okay, so this is how you delete a branch. Is you just type git branch -D. Don't delete your Wolfman branch yet. If you want to delete your pro-con list, that's fine, because we've merged in the changes we want. And it tells you deleted it. Now, if I look at my branches, if I type git branch, that branch is gone. So this can allow you to kind of clean up your repository. As if you get really excited about branches, or you make a branch and you realize you spelled it wrong and you just want to get rid of it and then start again. Okay, so are there any questions on this? Yeah.
So once you try to merge the branch, it says there's a conflict, you go and resolve the conflict in that file, and then as soon as you've committed that new change, it's merged?
Yes. Okay, so other questions? Yes,
I assume if you're in the branch that you're trying to delete, you'll get some sort of error.
I think so. You can try and make a toy branch and then go onto it and delete it. But yeah, I'm pretty sure that will happen. I guess we can try it. Yeah. Git gives you it tries to give you very useful error messages, and often they are. You know, this tells you exactly what's wrong. So if we go back to our master branch, then we can delete it.
So I make the changes and then it says it's not possible because I have unmerged files. So do I need to commit it before I merge it, or what?
Let me come talk to you. I'm about to put up an exercise, and then let me come sort through that. Okay, are there any other questions?
Well, later.
Okay. Okay, so this is the final exercise. If you finish, take down your green Post-it notes and then put them up when you're done. If you finish early, this is the book that I was recommending that's just online for free. You can kind of start to flip through, see what you've already learned, what you still have left to learn, and just get a sense of what that looks like. Great. Okay, so let's go over this quickly. Okay, so let me check out what branch I'm on. I'm on the master branch. I'm gonna go into my packing list, and I also want to pack some snacks. And I'll save that. And exit, and add my packing list, and commit my packing list. And then I'm gonna check out my Wolfman packing list. And I'm gonna go and edit the same line of that file, which was the last line, and Wolfman wants to make sure to bring his iPod. We'll add that. We'll commit it. Okay, check the branch. Okay, so now we want to merge into our master branch. So I'm gonna go to my master branch. I'm gonna go to the branch that I want to merge into. Make sure that worked. And now I'm gonna try and merge my Wolfman packing branch into my master branch. That doesn't work, it results in a conflict. That means I need to go look at my packing list, and it tells me there's both snacks and the iPod. In this case, I probably want to keep both. So I'm just going to get rid of these extra lines they added, and my combined file is going to be a combination of both my changes. So I want to save that, exit, add it, commit it. That's actually totally fine. I'm just merging my branches. And I merged. Okay, are there any questions on branching and merging? Yes?
So it looks like Mars.txt is still different in the two branches.
That's what I had, basically, he didn't make any conflict changes.
So like, because we didn't.
Because we just added like we just changed the top line. Is it?
Oh no, so not the packing list either. I'm showing on the Mars.txt that they're different in the different branches, but that when you merge, there wasn't anything that happened.
Oh, right. So it will merge seamless. So it will merge seamlessly if there is. So basically, I'm pretty sure. I don't know if you guys can see here. So what we had was we had our master, and then we made our branch our Wolfman branch. And then we made a change to master. So now Mars on our master branch looks different from Mars on our Wolfman branch, but the change on our master branch is more recent. So when you then merge Wolfman in, it's going to keep the change that you made in master because it's more recent and you haven't made any other changes to Wolfman. So they'll still continue to be different because it's saying, I'm going to assume that the more recent change you made is the one that you want to keep and you haven't made any subsequent changes. Does that make sense? Okay, other questions? Okay, so let's go to collaborating. And we're going to be using GitHub. Okay, so the whole idea of collaboration is that now you're moving off of your local computer. Everything that we've done so far just has to do with what you have on your laptop. You can do this on the airplane, you can do this in a remote tower, you can do this in a nuclear facility where you don't have internet access. Wherever you are, no internet. For a remote repository, you do need some kind of central location network, whether that's something you build on your own or you use something like GitHub or Bitbucket. You need some central place that everything's pointing to. So the idea here is this is what we've been doing so far. We had our file, we staged it with our ad, and we committed it. And now we're doing this final step where what's called we push to some kind of remote repository somewhere else. So there are two different services that do this that I think are most commonly used. There are other options out there. One is GitHub. GitHub's model is that by default, everything should be public. So when you make yourself a repository, anyone's going to be able to view it. They can't edit it, but they can view it and they can copy it. There are some, you can pay to have private repositories, and there are some repositories for like special where you get a few private repositories if you're at an educational institution or a research institution. So those are things you can investigate if that's important to you. Bitbucket is the opposite. They by default make your repository private, and then you pay to have public repositories. So it's kind of nice to know that both exist. They both work with Git. So this is separate. I know it's kind of confusing that GitHub and Git, they're often used almost synonymously, but Git is what you've been using so far. That's what's on your computer. GitHub is just kind of the online storage and interface that you have to that storage. Okay, so hopefully maybe you guys have made accounts on GitHub, sign into that, or make your own account if you didn't do that, and put up your green post-it when you're done.
So how do you get to those slides?
So this is, I'm sorry, I switched slideshows. So this is the, there's a link in the Etherpad, actually. This link right here, the collaboration slides. There we are. And I am going to do that too. Okay, so green post-its when you're signed in. When you're signed in, like I can tell I'm signed in as me because I have a little profile. When I click here, it says my username. There's also this right here. Okay, so green post-its when you have successfully signed in to GitHub. Okay, so the next thing that we're going to do is we're going to create a repository. So let me go back to my slides. Okay, so right up, if you're following along with your slides, I've circled things. But right up, I have a little profile picture. There's this little inbox. I don't know if you have a little blue thing, but right next to it is this plus. And if you hover over it, it says create new. And so if I click on that, I want to create a new repository. And that should bring me somewhere here. I'm going to call, I find it generally a good practice to call my remote repository and my local repository the same thing so that I know that they're linked to each other. So I'm going to call this one planets 2 because that's what I'm going to, we're ultimately going to connect this to the repository that we've been working on locally in our machine. Yes, I mean, it can be whatever you want, but I'm going to match it. My original one was all lowercase as well. By default, it's public. If you click private, it asks you for money. Your description is optional, but you can say planning our maybe escape from Earth. In this case, so there's two different ways that you can kind of set up a remote repository. If you haven't started something locally, you can create a remote repository and then clone it down just like we did with the software carpentry lesson materials for this class. And then you can go into that and you can start adding and committing immediately. In this case, we already have stuff, and in that case, it's nice to initialize it with some kind of file so there's something in there. We don't need to do that, so we're just going to say create the repository. Okay, so you should get instructions that look like this, and this is telling you how to connect your file, how to basically connect. So this set one here says push from an existing repository. This is what we're going to do because this is saying we already have a local repository and we want to now connect it to the remote repository. If you hadn't done that, then this is how you just start a new repository by cloning. So I guess you create your new repository and then this part is the part we already have. Okay, so I'm going to actually just copy and paste these two lines right here. And then I'm going to go to my command line. I'm going to make sure I'm in my repository. So I'm in my planets repository. And I'm going to paste it on. It may ask you for your GitHub username and password. So the first thing that we did is this git remote add. Just like you have a master branch, Git knows that you don't want to have to type the URL to your repository every time you want to put things in. So it gives you a nickname for it, and the default nickname is origin, just like master's like your default branch name. So this is saying, I want to add a remote repository link, that's this git remote add, origin is the nickname of that repository, and then this is where that remote repository is. If yours looks different, if it has an HTTP, that's just a difference in how like we've configured our GitHub accounts, basically, and how we link to them. Then the second line, this git push, is saying put what I currently have in my local repository to origin, which remember is the nickname of the remote repository, on the master branch. Okay, put up your green post-its if this worked for you. Yes.
It's giving me the port 443 timed out error message.
Okay, Matt, can I send you over here?
So I keep doing it twice. There was an error message.
Okay, for people who this worked for, what you can do is now, if you go to GitHub and you click on the planets repository, you should see your files. Just explore, start clicking buttons, see what they do.
Yeah, it's just like, can I say, how does it branches? When you push everything, I just want to see the branches. I mean, I have to push the branches.
Yeah, so push goes from local to remote, and pull takes you from your remote to your local.
You can't push from your, this is your info over here, you can't push from a different directory or something.
No, because what's that dot, remember the .git file when we did the git init?
All of it.
When you're not somewhere where that .git directory is, you have more the branch repository. That's where it stores like this remote, where we just told it where it's kind of working. That's all in that file. All of your differences are stored. You can create, when they get repository, you can create subfolders, and all those subfolders are
So I guess it's
and so you can push people
see.
Actually, just as much as you might for the developer aspect, the practices that user is using with like how can they do branching and stuff.
Yeah?
He's saying like basically anytime they're making changes to the repository, they always make it there, always. But like you just never edit master.
So when you discipline and start making a mess there,
Right.
it's gonna be a bigger mess then.
Because like if you have something that works, you want that to be the master, right?
Exactly, yeah.
Like any changes, if you mess that up, you don't want to just like reburn. So, yeah. So that was curious how they did it, because I was also wondering if like you do a person or something like that, like this way they just have a branch every time there's an issue with it. And they need to, which is, says a specific change they need to make. It says they make a branch, name it after the ticket, and then submit a pull request, put that back in, and then if they all agree, okay, and then they can.
Okay, you guys, a few just little pieces of information, final, before we start actually collaborating. Now that you've created a remote repository or are close to creating one. One is we've already seen this, but you can look at what branch you're on just with git branch. The other is you can say, what is my remote repository? Like, what does origin mean? By typing git remote -v for verbose. And this just tells you that you have something, this tells you its nickname, and these are telling you, this is when you bring stuff down from your remote repository, that's called fetching, and this is where it's bringing stuff down from. And then the second line is when you put things to a remote repository, this is where it's putting them. Okay, so now I want you guys to pair up. find a partner. And tell me who, and decide who's going to be Dracula and who's going to be Wolfman. Because from here on out, there are going to be directions for Dracula and directions for Wolfman.
It's my first time doing exercise.
What do you want to be? Oh, Michael?
Out of the two, I don't know if I have a preference. I can be Wolfman.
Okay, does anyone need a partner? Yes. Does Ted or does someone want to be a second? Okay, move on up. There's a seat right next to him. Okay, does everyone else have a partner? Okay, so the first thing, let me get back to my slides. We created a new repository, we explore, we did that. Okay. So the first thing is that Wolfman is going to clone Dracula's repository. So in order to collaborate with people, you both want to be pointing to one central repository rather than each pointing to your own, which is where we are. So the first thing I want you to do is get out of, this is just Wolfman right now I'm talking to. Dracula, you can just sit tight for a little while, but listen, because this is good information if you were on the other side. What I want you to do is CD out of the directory, CD out of your planets directory, because you don't ever want to create a repository within a repository. So for me, that's just a ... You can go a little bit further if you need to, if you're in some subfolder of your planets directory. But make sure you're out of your planets directory. And then you can make a new directory that's just called planets collab for like, I'm collaborating on my planets. Because you've already called, because you already have a folder that's called planets, you can't make a second directory called planets. So then go into that planets collab directory. So CD into it. So that's these 3 lines right here. So the next thing you're going to do is this clone command. You guys have seen this before, and what this does is it says, give me a local copy of this remote repository, and it stores information like where you got that from so that you can, if you're given permission, which is what we'll do next, you can actually write to it as well as read it. So this is how, if you just want like quickly to get a set of data, you can just, or a set of code, you can clone it. So the command for that will start is git clone, and then to figure out what URL you need, you want to talk to Dracula. Dracula's going to go to their repository and then right here, I'm not sure, how many people see something that looks like this? Let me see hands up.
It says HTTPS on the
Yeah. If it says SSH, then there's this button right here. You can click the HTTPS. So why don't you guys use the Etherpad? Dracula, you need to share this URL with Wolfman. And Wolfman, this is the URL that you're going to put after your git clone command.
So I'm not getting that.
Okay. Put up a pink post-it.
I'm not getting the URL.
I'm going to actually do it on the URL.
I have the URL. Yeah, I have it, but thank you.
If you put it on the,
You can use the Etherpad, you can read it out loud, you can hand write it, however you want to communicate that.
if you want to tell me, that might be easier.
I guess if you look here,
So like, so we could have done that.
Okay, guys, take your green post-its down and put them up when you have successfully cloned.
We're just doing that one way right now?
Yes, because you already have access to, look, Dracula has access to his or her own repository, but Wolfman is now, is now getting the read access and will do the write access next. Okay, green post-its when you've successfully cloned. Yes. Right now, yes. So, well, I'm just looking for Wolfman to have cloned. Okay, so the next step is that Dracula, you have to now add Wolfman as a collaborator. So you can clone anyone's repository. You can, and that's like equivalent to being able to read anyone's repository. But anyone can't write to your repository. So when you add someone as a collaborator, you're giving them write access to your repository. So you do this. This is for Dracula now. Go to your settings. And then this collaborators button here. And then you guys are probably not going to be prompted for your password.
Where was that?
Hold on one second. Let me get out of this. Okay, so from your repository under settings, and then collaborators, and then Wolfman needs to give you their GitHub username. So I could add Matt as a collaborator.
Like that? No, E. The letter E. Letter E. Letter E. Oh, okay. And then the letter I. No, I. So, okay. There I am. Elizabeth C. The fourth one down. That's it. Yeah, that's over. Cool. How do we do? Okay, get it. My hair used to be red. Oh, well. Yeah.
Okay, you guys take your post-its down, put them up. If you've successfully, if Wolfman has a cloned repository and has been added as a collaborator.
Yes.
Awesome. Okay, so here's the idea. Wolfman's going to make some changes. He can push them to his remote repository. You guys are both looking at the same remote repository. Dracula can pull down those changes. Dracula can make changes, can put them in the remote repository. Wolfman and Dracula can make changes at the same time, but one of them gets to push first, and then once, like let's say Dracula makes changes, Wolfman makes changes, but Dracula finishes his changes first. He pushes them up to the repository. Wolfman can't push his changes up if they conflict with Dracula's changes. What's going to happen is that your Git is going to say you need to pull down Dracula's changes, resolve any conflicts, and then you can push that conflict-free file back up. So just like we were doing the conflict resolution with the branches, you can have conflict resolution between two people. And Git trusts both of you equally, basically. And so whoever puts it in first, the second person has to figure out how to resolve those conflicts. And you have to resolve them locally. So let's look at kind of how you put things in your repository and how you get things down from your repository. Okay, so Dracula, first, what you are going to do is modify mars.txt, save your changes, add and commit them, and then you're going to use this command which pushes them to your remote repository. So this is going to put the changes you made to the remote repository. You just say git push. Origin, remember, is the nickname you've given that repository, that remote URL, and then master just is saying, I'm working on the master branch and I want it to go on the master branch. So then what Wolfman can do is, Wolfman, you pull the changes down with this command, git pull, and the same thing. You're saying, I want to pull from origin, which, git, you know what that means, and then master. And then Wolfman, you can add a line at the end of the file, you can save it, you can commit it, and you can push it. So go ahead, take your post-its down, Dracula, do your thing, Wolfman, do your thing, and then put those post-its back up.
Do you have, I don't think I have, this is just one particular file.
And we're working on, Dracula's working in the original Linux directory, right?
Yes. Yeah, Dracula, you connected that.
I want to change Mars text, and I've now committed it.
Let me see, Wolfman, I'm sorry, Wolfman, you need to CD into the directory you
So I just
closed.
opened
I did not mention that. So we made this Planet Collab directory, but then you clone the Planets directory. If you ls where you are, you should see that Planets directory. CD into that because that's your repository.
So, yeah.
You need to remember to change that.
So I did the push, and
So, okay, thank you.
So doing all the.
You're copying my file.
You had an extra line, right?
Did, so I added a line.
I did it commit.
So I can go ahead Great, so, okay, so I'll do git pull for all of this. Yeah, I think one file
Origin's not made.
Great.
How do I know what the name is? It's origin or?
This is all new. Cool, okay, so now I can Oh, wait a minute, I don't see.
Go to,
Dracula's on.
okay, so I was using that. So I need to
Oh, yeah, let me check.
The way the exercise is set up, that everyone makes plans. And so if you try to make all active plans at the same level,
Shouldn't get too into the actual changes here.
so you need to kind of go down a level in order.
Let's see, so you save it in
And then you have to,
yeah.
oh, you already did,
Now I do the adding.
yes, so I have to open it and then you have a copy, right? That's expected to have.
I don't think so, because I pulled your changes.
Yeah, you pull my changes and then you add something. You're not gonna have anything in public. Right, yeah, we won't have anything. Right, right. That's gonna be fine.
I need to do git push. Mars comment. Oh, that's a comment.
I still do that.
Thank you. my changes were updated on GitHub.
Collaborator.
I don't understand why you have the conflicts because I made changes to both, switch it again, push it back. So basically, well, maybe if I try to match those changes with mine.
It sort of depends on what we're doing next, but my guess is that like, so now the GitHub repositories change, my thing matches it, but your local version doesn't. So I bet the next thing we're gonna do is you're gonna change
I
the
have
local
to try
version.
to pull,
But that,
will have,
yeah, but that'll be the next step, so that's how they have this exercise. So my guess is they're gonna ask you to change the local version.
yes, I do. Okay, so maybe, okay, but I need to see, okay, yes, I have to try to pull down changes. That's what I have to do.
So now you guys want to edit the local files, but we should probably oh, it's already new.
Yes.
Hey, you guys repost this stuff when this works.
Just like,
Okay, so we're not gonna have time to test out conflicts because we're already into lunchtime. I will stick around for maybe the next 10 minutes if you want to do that, if you want to try that with me. It's just like what we've been doing, what we did with merging, where you're going to try and push your changes and it's going to say you need to pull down changes before you push. You're going to pull it down. It's going to tell you you have a conflict and you resolve the conflict in the same way. So let's break for lunch now. We'll meet back here at 1:05. 1:10. Give you an extra 5 minutes for lunch. And let me know if you want to actually try resolving a conflict.